Let's see. And Sirki, my favorite student. A book is sitting on a level desk. Which of the following statements are true? All right. There are no forces acting on the book since it's not accelerating. Can you have forces acting on you and still not be accelerating? Yeah, all of you have a force acting on you right now. What's the obvious one? Gravity. Are you accelerating into the ground? No. Are you lifting into the air like Superman? No. Then there must be an exact and counterbalancing equal force, the opposite direction of gravity. Doesn't mean there's no forces on you. Now, if this had, so this one here is false. If it was true, it would be true if I had said it's not accelerating, so the net force is 0. That I would have lived with. Oh, which suggests that C is going to be true if I skip down ahead. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. Think so? Sounds good. I had to word it very, very carefully, and I spelled magnitude wrong on the second magnitude, but I did this on a Mac, and I can't fix it because all I have is my PDF copies, and I can't edit a PDF after the fact very easily. It can be done, but it's not worth it. I live with that spelling mistake, and as a teacher, I always notice spelling mistakes. They drive me crazy. The friction force is what's holding the book on the desk. I don't think so, because I think the desk could be made of ice, and I can certainly, as long as the desk is flat, put a book on an ice desk, and it will stay there quite nicely. So I think that's false. Speaking of falsehoods, number 2, a many-body problem. Hey, we looked at this last day. So it says find the acceleration of the entire system if mu is equal to 0. I'm going to do a free body. Okay, I'm not going to do a free body diagram because a free body diagram would be rewriting everything separately as dots. I'm going to label the forces because it didn't say specifically to draw one, so I'm not going to bother. I'm going to instead say what are the forces acting here. I'm pretty sure I have M1G, normal force number 1, tension. M2G, normal force number 2, tension, and F applied of 24. I think my equation is going to look like this. Winner minus loser plus winner equals M1 plus M2 times A. I think I would say, I'm relaxing even with 3 students late, because tension is vanishing. And then I would divide by both masses. So I'm going to get 24 divided by 20. That's going to be divided by 4 divided by 6 over 1.2 meters per second squared. If you got the 1.2, you get 2 out of 2. Otherwise, I would probably give you 1 mark for the equation. I'd probably go something like this. 1 mark for that equation if I saw that, half mark if I saw that, and then half mark for the answer. But if you got the full answer, 2 out of 2. Find the tension between 2 masses. I'll look at the left-hand mass. I could find it with the right-hand mass, and Emily, if you did, that's fine. You'll get full marks. The left-hand mass has fewer forces, so I'm going to be clever and assume there's probably going to be a little less room for me to make a dumb mistake along the way. Who's winning on the left-hand mass? Only tension. Who's losing? Ain't one. So it's going to be M1A. Hey, cool. I can just crunch the numbers. Tension is going to be 8 times 1.2. 8 times 1 is 8. 8 times 0.2 is 1.6. 9.6 newtons. 2 marks, I guess 1 mark for the equation, 1 mark for the answer would work. Oh, by the way, welcome Sebastian to our class. Yay. This Sebastian. We have 2 now. Yeah. Number 3. All right. Same question, except now mu equals 0.12. Have I finished question 2 completely? Then I'm going to use the same diagram and just add friction because I'm going to gamble that it won't. I'm not going to need the diagram without friction anymore. So I'm going to say, oh, there's also friction force number 1. And there's also friction force number 2. So my equation's going to look a little bit different. It's going to be winner minus loser minus friction force number 2 plus winner minus friction force number 1. Oh, it's 50 newtons. Why did I change it to 50 newtons? I had to change it to 50 because 24 wasn't enough to get it moving. Thank you. Read the question carefully. And that's still going to be M1 plus M2 times A. Yay, tension cancels. How would I get the A by itself? How would I get the A by itself? Anyone? Can I do that in one step? I'm going to go A equals 50 minus, now friction force number 2. Friction is what times what? It's mu times the normal force. Don't you dare say mu mg because it's not. It's mu times the normal force, but I don't know the normal force. Oh, but look. I know another force the same size as the normal force. So I can say mu m2g minus, and friction force number 1 ends up being mu m1g. And that's going to all be divided by m1 plus m2. The acceleration is going to be 50 minus 0.12, 12 times 9.8 minus 0.12, 8, yes, times 9.8, all divided by, I'll add the masses together in my head, 20. What do we get? I have no idea what you said. 1.32. Anybody else? Yes, 1.32 meters per second squared. 1.32 meters per second squared. Pause for a second. Let's keep going. I bet you B is going to ask for the tension. Hey, it is. Tension. Which one's going to be easier to find the tension in? I still think the left-hand one, because the right-hand one has 3 forces on it. It has one force to the right and 2 forces to the left. So I'm going to go with the left-hand mass. Who's winning? Who's losing? Friction force 1. That equals, and since I'm only looking at one mass, M1A. Okay. Oh, how would I get tension by itself? Plus friction over. M1A plus friction. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Once again, M1G. Don't count on that. Starting next week, that changes. So we have this. Tension equals, what was M1? 8. What was A? 1.32. Now, if you put your number in here, the one that you got last night, and you did everything correctly, you went 8 times 1.32 plus, what was mu? What was mu? And you went 0.12 times 8, Mr. Dewick. Let's write an 8 times 9.8. I knew there was a 9 coming somewhere. If you did that, you get 2 out of 2 on this question, okay? Assuming you typed it right on your calculator, which is maybe a bigger assumption than, shut up. What do you get? What's the tension? 20? 20.0? Yes? No? Yeah? 20.0 units, Sebastian? Newtons. You got to get used to this too, you know. And unfortunately, you're right in a line with each other. Sebastian, we'll do that. The classic elevator question. I'm asking you to tell me what a scale reads. Hey, by the way, what does a scale measure? Yeah, normal force. That's key. That's the trick to solving this question, because then I would argue, Courtney, it falls apart. You draw a free body diagram. Let's draw the free body. First person. Here's the person. What are the forces acting on him? I got mg down. Which way are they accelerating? Up. So I'm pretty sure the upwards force, the normal force, is bigger. So now, Emily, I can say who's winning. Normal force is winning. It's going to be winner minus loser equals ma. I'm pretty sure the normal force is going to be ma plus mg. Do I know the mass? Yeah, 60. Do I know A? Oh, they told me 1.2. Do I know the mass? Yeah, 60. Do I know A? G, 9.8. What'd we get? 660 newtons, sounds right to me. 1 mark for this equation. 1 mark for the answer. B, the elevator accelerates downwards. Okay, in that case, gravity is winning. Normal force is losing. That free body diagram takes all of 1 second or less to sketch, and it's so helpful, I think. It's going to be mg minus normal force equals ma. I think the normal force is going to be mg minus ma. The normal force is going to be 60 times 9.8 minus 60 times 2.25. What we get? Anyone? Sorry? 516? Anybody else? No? 453 sounds right. Newtons. Maybe you read the answer for C, I don't know. Oh, that was, oh, never mind. No, you know what? That was a great mistake to make on a quiz that hardly counts for anything, because you'll read the question more careful on the test, more carefully. Your English will be more gooder too. C. What's the key phrase in C? Constant velocity. So here's my free body diagram. I got mg down. Now, this one's a bit weird. I'm a little scared, but it does say it's going up, so I'm going to guess if there is a winner, I'm going to say maybe it's the normal force, because we are going up. If I'm wrong, hopefully I can still physics my way out of this. Let's see. It's going to be winner minus loser equals, the fact that it's a constant velocity, what am I going to put on the right-hand side? What's my acceleration then? 0. In fact, Seb, if I was really clever, I might have seen as a shortcut, I might have said, you know what? If it's constant velocity, what really we're saying is that these two are equal. Great. So it's going to be 60 times 9.8. 588? And this is what Einstein said. Einstein said, you know what? If you're in an elevator in outer space, you can't tell if you're moving at a constant speed or if you're standing still. And the fact that you can't tell, that means that motion is relative. Doesn't matter. The rules of physics don't care. And then he also said, now if you can't tell if you're moving or at a constant speed or standing still, what if you feel a force? If you feel a force applying against you in outer space from the floor, you can't tell if it's gravity or if it's acceleration. And that kind of led him into how gravity worked. He said, I think gravity is a form of acceleration. It's a warping of space-time. Anyways, his elevator analogy was pretty good because most of us have been in one. The elevator is accelerating downwards. It's in free fall. Well, if it's in free fall, it's accelerating downwards. I think I can say that mg is winning. I'm not quite sure what the normal force is going to, I'll draw it on there. I'm not quite sure. I'm going to get this, winner minus loser equals ma. If I get the normal force by itself, I'll get it equals mg minus ma, and I'll get mg minus m, and it says a is 9.8. Oh! And maybe I could have figured this out because I'm good at physics and leapt to the conclusion right away, but I've just proved it. What is the normal force? What does the scale measure? That's why you feel weightless in free fall. Are you truly weightless? No, gravity's still acting on you. See. We call this apparent weightlessness, and this is what the astronauts are feeling. The astronauts are only about 300 miles away from space. Believe me, they feel gravity, but they're in free fall. We'll talk about this more when we look at orbits. But they're in free fall, they feel apparently weightless. Oh, and because the container that they're in is also in free fall, they can't feel the air rushing on their face. So they really have no way of telling that they're in free fall other than the fact that I'm apparently weightless. Okay. Can you give yourself a score, please, out of, count 'em, 19? Yes, absolutely. If you were clever enough to say, you know what, I know enough physics that I've reasoned it out. I can imagine standing on a scale, jumping out of an airplane. Have I mentioned I jumped out of an airplane? And I'm pretty sure that the scale would read 0. Yes. You know what I just did? I proved it right? Which the nerd within me kind of likes to do sometimes.